Hello friends, welcome to KLE College of Education, Ankola YouTube channel. I am Vidyashri Joglekar. Today I am going to discuss on the ninth standard science unit, that is matter in our surroundings. As we look at our surroundings, we see a large variety of things with different shapes, size and texture. Everything in this, scientists have named them as matter. The air we breathe, the food we eat, stones, clouds, stars, plants, and animals, even a small drop of water or a particle of sand, everything is matter. Anything that occupies space and has mass is known as matter. It has both mass and volume. Physical nature of matter. Matter is made up of particles. When salt is added to water, after stirring salt, we will mix it with water. Hence, we can know that the matter is made up of particles. It is a physical nature of matter. To estimate how small are the particles of matter are made, the experiment by adding potassium permanganate in 100 ml of water, the particle of potassium permanganate states to mix slowly in water. The color of the solution in the conical flask changes its color while increase in the amount of water. Characteristics of particles of matter. Particles of matter have space between them. In every particles there are space between each other. Particles of matter are continuously moving. When the potassium permanganate is added to water, the particles of water starts to move. Particles of matter attract each other. Potassium permanganate attract with each other to form a solution. Hence, we can conclude that matter are made up of particles. Particles have space between them and continuously moves, and the particles of the matter attract with each other. States of matter. Observe different types of matter around you. We can see that matter around us exists in three different states: solid, liquid, and gas. These states of matter arise due to the variation in the characteristics of the particles of matter. Now, let us study the properties of these matters in detail. Solid state. A book, pen, needle, a piece of wooden stick, etc. are the example of solids. We can observe that all these have definite shape, they have distinct boundaries and fixed volumes, they have negligible compressibility, they have a tendency to maintain their shape when subjected to outside force. Solids may break under force, but it is difficult to change their shape, so they are rigid. The liquid state. They have no fixed shape but they have a fixed volume. They take up the shape of the container in which they are kept. The particles move freely and have greater space between each other than solids. Liquids flow and change shape, but they are not rigid, but they can be called as fluid. The solids, liquids, and gases can diffuse into liquids. The rate of diffusion of liquids is higher than that of solids. Gaseous state. This is also known as gas. They have no fixed shape but they have a fixed volume. Gases are highly compressible as compared to solids and liquids. The particles of gas have large space between them and show the property of diffusing at a faster rate. The liquefied petroleum gas, so called as LPG cylinder that we use in home for cooking, and the oxygen supplied in the hospitals in cylinders is compressed gas. Compressed natural gas CNG is used as fuel these days in vehicles. Matter changed state. We all know that from our observation that water exists in three states of matter: solid as ice, liquid as familiar water, and the gas as water vapor. Effect of change of temperature. Take about 150 gram of ice in a beaker and suspend a laboratory thermometer so that the bulb is in contact with ice, as shown in the image. Temperature at which a solid melts to become a liquid at the atmospheric pressure, it is known as melting point. The melting point of ice is 273.16 Kelvin. We inferred that the state of matter can be changed into another state by changing the temperature. Effect of change of pressure. We have already learned that the difference in various states of matter is due to the difference in the distances between the constituent particles. What will happen when we start putting pressure and compress a gas in an enclosed cylinder? Will the particles come closer? By applying pressure, particles of matter can be brought close together. So we can say that the pressure and temperature determine the state of a substance, whether it will be solid, liquid or gas. Evaporation. There are many examples from everyday life where change of state from liquid to vapor takes place without the liquid reaching the boiling point. Water, when kept uncovered, slowly changes it into vapor state from the forces of attraction of other particles and get converted into vapor. This phenomenon of change of a liquid into vapor at any temperature below its boiling point is known as evaporation. Factors affecting evaporation. An increase of surface area. We all know that the evaporation is a surface phenomenon. If the surface area is increased, the rate of evaporation increases. An increase of temperature. With the increase of temperature, more number of particles get enough kinetic energy to go into vapor state. A decrease in humidity. Humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in the air is already high, the rate of evaporation decreases. An increase in wind speed. It is a common observation that clouds dry faster in windy day. With the increase in the wind speed, the particles of water vapor move away with the wind, decreases the amount of water vapor in the surroundings. How does evaporation cause cooling? In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surroundings makes the surroundings cold. What happens when you pour some acetone or nail polish remover on your palm? The particles gain energy from your palm or surroundings and evaporate, causing the palm to feel cool. The plasma state. The state consists of super energetic and super excited particles. These particles are in the form of ionized gases. The fluorescent tubes and the neon sign bulbs consist of plasma. Inside a neon sign bulb, there is neon gas, and inside a fluorescent tube, there is a helium gas or some other gas. Electrical energy flows through it. This charging up creates a plasma glowing inside the tube or bulb. The plasma glows with a special color depending on the nature of gas. The sun and the stars glow because of the presence of plasma in them. The plasma is created in stars because of very high temperature. If you like the video, don't forget to like, share, subscribe and comment. Thank you.